Right, good evening. So last time, last time we finished nomenclature part. We finished it, and I gave some example questions, right? So I asked you some example questions. Uh, so today we have to talk about isomerism. Before that, I'll finish that homework, right? So there are a few examples, right, about questions about nomenclature, right? I gave few formulas, right? Chemical formulas, right? Structures. So you have to name it, right? So I think I gave 5 6, huh? So I think this is the first one, right? I think this is the first one. CH, I use black one. Here it's CH3, yeah, something. I think you cannot see that. CH3. Uh, so then what is the first thing that we need to do? We have to find the carbon chain, the suitable carbon chain, right? So what are the conditions that we check when we find the long chain? Uh, that long chain should connect with all the groups, right? Groups and the major group, right? So another thing is it should contain these double bonds and triple bond if present, right? If there are any double bonds or triple bonds, right? Called unsaturation, right? Unsaturated bonds. So you have to take it into a carbon chain, right? So those are the conditions that we follow, right? Then then we have to find the main group, right? Major group, right? So here it's carboxylic group, right? So if carboxylic present, so that's the main group. Okay, then so let's name it, right? So let's name the carbon chain. So we have to give the minimum number. We have to give the minimum number to the major group. So we will start from here: 1, 2, 3, 4, 5, 6. And another thing, just remember in the exam, the maximum carbon chain that you get, right? The maximum carbon chain, I mean main carbon chain, not the number of carbons in the molecule, right? I'm not talking about I'm not talking about the number of carbon, right? This is not the number of carbon. I'll say the number of the main chain. It's 6, maximum 6, right? Number of the major chain, right, or stem, right, is 6 carbons, right? If you count all the carbons with the groups and all those things, you may get 8 9 maybe, right? So I don't know, But the main chain, the maximum number is 6, right? You never get higher than 6, right? So that's why we only gave up to hex, right? So just keep it in your mind. So most of the time, that would be the maximum. I mean, the carbon chain, it goes 5, 6. That's it, right? So if you get when you count the carbon chain, and if you get 7 or something, 7, 8, most of the time you are wrong. Huh? Most probably you are wrong. You found the wrong step, right? That's the conclusion. So keep it in your mind. Maximum is 6. They don't give more than 6. I mean main chain. Then okay, let's write. So here first carbon chain. Follow these guidelines, and when you do it at the exam or after you practice it well, you don't need to write like this, right? So up to here, just follow, at least follow. You don't need to write like this, just follow these guidelines. Highest priority group, highest priority group, and then unsaturation. Right, so you have to follow these things. This is the first this is the how many carbons, so you have to count it, find the number. So there are 6 carbons in the group, so therefore hex. And then priority group is carboxylic acid, right? So you name it as oic acid. And then next one, unsaturation. So here it's double bond in 4th carbon. So ene, right? O ene. Then parent hydrocarbon name hex 4-ene, right? Hex 4-ene or 4-hexene. So what are substituents? This one and this one. Two methyl, this is ketone group. So three what? Three. If it's a main group, it's all, but here it's as a substituent, we call it oxo. And there is another one that I forget. CH3. No, wait. Here it's not H. This is not H. Huh? Here it's double bond. So then 2 5 methyl. So then let's combine all together, and so first we have write the substituents. So which substituents come first according to the algebra? So which one? O M D D F G H I J K L M. So M is the first. So you can write. You can start from 2,5 dimethyl, 2,5 dimethyl, 3-oxo, 3-oxo-hex, 4-enoic, right? We cut the E, acid. Or you can write 3-oxo, 4-hexene, noic acid. I think this one is a little bit easier. Right, both are correct. Then the next one, I'll move to next one. So let's do this quickly. Anyhow, we have today. Today we have to finish this lesson. Is the next one? Right. So here, what is the main carbon chain? We have to take this straight chain. So here, what is the higher priority group? It's NH2 group, right? NH2 group. Wait. Here, not NH2 group, right? That is alcohol only, right? So alcohol is higher than what? NH2 group, right? So this is the highest priority one. So these are additional groups, right? So then we have to find the carbon chain. So we have to numbering the carbon chain according to the, mainly considering the OH, right? So the condition is the lowest number should, the highest priority group should get the lowest number, right, when you counting. So just count it according to that, right? So which is given to the lowest number to the OH group, right? So which side, left to right? 1 2 3 4, right to left, 1 2 3. So here again this side is correct, so let's count it like that, numbering it 1 2 3 4 5 6, right? Then this is correct, X correct. Higher priority group 3 all unsaturation, 4 in parental hydrocarbon, hex ne, hex 4 in the O, or you can write 4 hexene. Substitutions, substituent 2 5 dimethyl, and then what is NH2 group? What is NH2? 1 amino. So then what is the name? We have to start from amino because A is the first in algebra. 1 amino, 2 5 dimethyl hex, 4 in all, O dimethyl, same as here, dimethyl 4 hex, enol, hexenol. Sorry. Oh, then 4 in මෙතන 3 නෙන්නේ. sorry. මෙතන මෙහෙම නෙමෙයි. මෙතන ඉන්නේ dimethyl hex. මේක දාන්න හැමෝටම මෙතන දැන් නැහැ. dimethyl hex dimethyl මෙතන ඉස්සරහට දාන්න. dimethyl hex 4 in ටික හරි මම මෙතන ඔයික් ඇසිඩ් වගේ නෙමෙයි මේක තියෙන මෙන්ෂන් කරන්න බෑ. in මෙතන හරි in 3 all, right? Hex in 3 all, or you can write dimethyl 4 hexene for hexene 3 all. Right. Year cancel වෙනවා දෙකෙන්, right? මෙතන මෙහෙම මේජර් වෙන්න ඕනේ. ඊට පස්සේ next one මේ exam level එකේ ඒවා, හරි. ඔය වගේ තමයි exam එකේ තියෙන්නේ. So we have to find the main carbon chain. So what is the main group here? The main group is all, I mean not all, that ketone group. So when we count from either side, right, so this group get 3, same number. So therefore we have to find the we have to give the numbering according to the substituents, right? So we have to numbering which is give lowest number to the substituent, right? Because either side, when you count from either side, this group, I mean the highest priority group, get the same number. So therefore we have to consider about the substituent groups, right? That's the way. Right, so which side gives lowest numbers for both group? If we start from this side, 1 2 sorry 1 2 3 sorry here 1 2 3 4 5 OH get 1 and CH3 get 4. If we count from opposite side, 1 2 3 4 5, then these substituent groups get 2 and 5. So 1 and 4 is better, that's lower. So therefore we have to go with that direction, right? So right to left, we have to go with right to left. So counting into that direction. Then name it. Carbon chain pent. Fine, pent. Then highest priority group, ketone group. So 3 ONE, right? 3 on, and then here unsaturation, no unsaturation, no unsaturation, parent hydrocarbon in pentane substituents, 1 hydroxy 4 methyl. The මේ වගේ තියෙද්දි, right, so in this kind of situation you have to count it, right? Otherwise you may do something incorrect. For methyl, right, then name, pent. So we start from here. H, which one is which one comes first? So H comes first. So 1 hydroxy, then 4 methyl, then pentane for methyl pentane, how many spaces, methyl pentane. So here is, we cut the E and we put 3 on, pentane on, 3 on, or we can write methyl 3 pentanone. Both are correct. Right. Then the next one. So, right. Correct. Fine. Correct. Then here we can do here. How many carbon? So this here it has only one group, so that one. So obviously it will come as a prioritized group, right? So I'll count according to the according to give the lowest number, right? The number system. So which direction is better? Because there is a unsaturation. So we have to. So when we count left to right or right to left, so either side give the same number to the OH group. So therefore we have to consider about the unsaturation. So then which side gives the lowest number to the unsaturation? This side. Right? 1, 2, 3, 4, 5. Right. So therefore normally carbon chain is, there are 5 carbons, pent, then penta, three all, unsaturation 1 in pent 1 in or pent 1 pentene. Substituents, no substituents. The name, what is the name? Because there's only one, I mean, here only one priority, right? Only the priority group. So no any substituent, therefore nothing in front of the main, hydrocarbon name. Pent one in 3 all, not, or you can write 1 pent 3 in all. Sorry, man. 1 pentene 3 all. So, correct. In this one, so let's do this quickly. First, find the carbon chain. So what are the groups? OH till. So what would be the main chain? This one. So mark the. This is the priority group. Right. This we can take these things as substituents, and this one also. And so which side gives the lowest name? Here. In either side, this one get the same number. So therefore we have to consider about the substituent. So which side gives the lowest numbers to the substituent? Right to left. So count from right to left. 1, 2, 3, 4, 5. Okay, then carbon chain 5, therefore pent has priority group or ketone group. So 3 on unsaturation 4 in parent hydrocarbon pent 4 in 4 pentene. Substituents 2, 4. 2,4 dimethyl. And 1 hydroxy. So combine together. So hydroxy come first. For dimethyl and for ene. Three on, or you can say ethyl 4 pent. Pentene 3 on. Right. Here there is a problem, right? The way we name it, we did a small mistake, right? So what is that mistake? The number in the carbon chain, right? So here in this kind of situation, we have to give the lowest possible number to the unsaturation, right? To the unsaturation. Okay. Before we, in this case, as I did, it gives the lowest possible numbers for the substituents, but the way we name the carbon chain, right? When we name the carbon chain previously, so we give the lowest possible number to the unsaturation. So we have to consider about the unsaturation, right? There's a small, you may have a little bit confusion, right? So these things, the wrong thing is the numbering part. Therefore, the name also kind of correct, but the positions are different. Okay. So let's correct it. 1, 2, 3, 4, 5. So priority group, that can get 3, it's okay. And in, it's 1 in. Here it's 1, everything is 1. And then here this one also similar, right? 2, 4 dimethyl. Only hydroxy is changed, right? And 3 in. Here it's 1 pentene. 1 in 3 all, right? 1 in 3 all. අතන කවුන්ට් කරපු මෙතඩ් එකේ අර මේ මම අරක කන්සිඩර් කරේ නෑනේ. එතකොට අන්සැචුරේෂන් එකට තමයි දෙන්න ඕනේ. Right, I think it's clear. The numbering and then it's done. So then the last one. So you don't need to write like this all the time, right? So until you practice this, then just follow these things. Then CH2 CH C H CH3 CH2 CH3 So here let's count. So the middle, the ketone group is the highest priority group. Then we have OH group, and if you take the middle, we have to get this chain because we need to catch the whole, full double bond, right? So if you go like this, you may get higher number, but higher carbon number, but the double bond goes away from the carbon chain, right? So therefore, it doesn't matter here. It's what is the number here, right? Carbon number. We have to consider this one, because if we consider about the highest chain like this, the double bond is out, right? So that's not the way. So then the next problem is which direction, right? Which direction? Here, either side, if you count, the which one? Ketone group get the same number. Therefore, we have to consider about the unsaturation. And we have to consider about the unsaturation. So give the lowest number to the unsaturation, right? So start from here, right? Then we have to take this one as a substitute. 1, 2, 3, 4, 5. 5 carbons, not 6. Five means spent. Highest priority group, ketone group. So therefore 3 on unsaturation, 1 in parental hydrocarbon, 1 pentene, just we can write pent, 1 in bracket 1 pentene. Substituent 2 ethyl, 2 ethyl, 2 ethyl group, 4 methyl group, 1 hydroxy. So which one comes first? E, ABCD E. So 2 ethyl, 1 hydroxy, 4 methyl, 4 methyl pent, 1 ene, 3 on, O methyl, 1 pent, 1 pentene, 3 on, right. Hari okay, it's done. So there is a small part called trivial name, right? So you don't need that thing. Just you will learn it when you do the lesson, right? Trivial names. So there are some common names, right? So acetic acid, right? So for acetic acid means CH3COOH, right? So we call this as acetic acid, right? So what is the IUPAC name? Ethanoic acid, right? Likewise, okay. There are some names. The common names, right? The common name එක අපි දැන් කතා කරද්දි තේරෙනවා දැනගන්න පුළුවන් ඒකින්ද වෙනම කරන්නේ නැහැ වෙනම කියන්නේ චූට්ටක් තියෙන්නේ common names කීපයක් දෙන්න තියෙන ඒක ඕනේ නැහැ. So let's move to the today's lesson, the main part, isomerism. Right. Write down the topic isomerism. Right. So Lamai, what is isomerism? Isomerism means when molecules have same molecular formula, right? Same molecular formula. They will show this isomerism. What is this? That's the main requirement, right? To show the isomerism, molecules should have the same molecular formula. Without molecular formula, same molecular formula, no isomerism, right? So actually isomerism means it's a kind of structural difference, right? It's structural difference, right? Structural difference in the molecule, right? So the same size, same molecular mass, but different structure, different arrangement, okay? So that kind of situation we call isomerism, right? That molecule. There are different type of isomerism. Okay, just write down the definition. Isomerism is the write down. Isomerism is the existence of isomerism is the existence of different compounds that have the same molecular formula. Different compounds that have the same molecular formula. next point. So underline isomerism, and then second point, different compounds having the same molecular formula. Different compounds having the same molecular formula are called are called are called isomers. Are called isomers. Are called isomers. Right. So then the first part. So isomerism mainly divided into two types. Right. We call constitutional isomers and stereoisomers, right? Constitutional isomers and stereoisomers. Right. So here the first we will talk about the constitutional isomers, right? So it's very simple, right? So you can understand it, and we don't talk about much, right? So we just understand it, and those are very simple, right? In constitutional isomers, it's about the arrangement, right? Arrangement of the structure, right? So as we said, isomers also arrangement of structure, but here there are three types of constitutional isomers. So just write down the subtopic constitutional isomers. Constitutional isomers. So it's mainly about the connection, the way those atoms connected with each other, right? So there are three type of constitutional isomers. First one, chain isomer, right? Chain isomers. Second one, position isomers, and the third one, functional group isomers. Functional group isomers. Okay. These are the types, right? First, let's talk about some examples. Okay. So here, before that, just write down the definition of constitutional isomers, right? So we call it as structural isomers also, right? Structural isomers, constitutional isomers, or structural isomers. Okay. Just write down the definition. Isomers that differ from the order in which the constituent atoms are connected to each other are called constituent isomers. Are called constituent isomers. Are called constituent isomers. Right. So example, C6H2A, right? Sorry, C5. So what can be? So you can make it straight. CH. then another one, so you can change this structure. Right. So this kind of arrangements. So actually, as you see, due to this change, right? Due to this structural change, these molecules show very different properties, right? Their melting points, boiling points, right? Maybe densities, right? Also can be changed, right? So that much affect this structure, right? But both, all these three have same structure. The formula, same molar mass, but they show different properties depending on the structure, right? So write down this example. So all those structures are constituent isomers, right? Constituent isomers. Or you can say isomers of each other, right? Constituent isomers of each other. එකිනෙකාගේ මේ එක එක අයගේ isomers, right? Right, then write down first type, chain isomers, right? Just write the first one, chain isomers, okay? Chain isomers. So here actually this kind of arrangement called chain isomers, right? It's a change of main carbon chain, right? Carbon chain, right? Okay. So only the carbon chain is changed, right? Structure, carbon stem. Okay, just write down under the chain isomers. Chain isomers are those which have different hydrocarbon chain, for same molecular formula, chain for same molecular formula, right? So I'll go with example. Write down this example. Right. So look at these molecules. So molecular formula is same, right? And the functional group, that one also same, similar functional group. But the carbon chain is different, right? If you name these carbon chains, I mean the molecules, you will get different name actually, right? So that's another thing. If you name these things, you will get very different name, right? Not the similar name. Okay. This one pent uh, pent pentanol. This one uh, two yeah, sorry, one 3 methyl uh, butanol. This one what 1, 2, 3 2 dimethyl propanol, right? 2 dimethyl propanol. So different names, right? So understand the difference. Only the carbon chain, that's why you call chain, right? Chain isomers. Then next one, position isomers. Second one, position isomers. Write down position isomers. In that case, in the position isomers, it will change the position of the functional group, right? Position of the functional group. Position of the functional group. That's why you call position isomerism. Right, look at these examples. What is the formula? 1, 2, 3, C4H. C4H6 ne? Make it. Look at the different, right? Even if you name it, just name it by yourself. What is the different? OH group is changing, right? So at this one, first one, it's at the end, but here it's middle. So here, triple bond. In this molecule, triple bond at first position. Then this one, it goes to the second position, right? Then, right. Okay. Just write down the definition of functional isomers. Functional group isomers. Position. We are in position isomers. Write down position isomers. Position isomers. Position isomers are those. Position isomers are. Position isomers are those which have. Position isomers are those which have the same functional group and dash or substituents, right? And dash or substituents in different positions hit the same carbon chain. Here, even if there are another substituent are present, right? So if that substituent positions change, that one also under position isomers, right? Functional group එකක් විතරක් නෙමේ, sorry, main එකයි. Priority group එකක් විතරක් නෙමේ, මේකේ substituents තිබ්බත්, right? Functional group එකේ substituents ඒවා change වුණත් position තමයි. Position එක ගන්න change වෙලා තියෙන්නේ. Right. Then the third one, write down the third. Wait. Before that, just write the examples. These are the examples. Right. Then write down the third one. Functional group isomers. Right. Functional group isomers. Right. Functional group isomers. So in this case, the functional group is changed by keeping the same molecular formula, right? That's the case. Don't misunderstanding these two terms, position isomers and functional group isomers, right? In the functional group isomers, functional group is changed. In the position isomers, the position of the functional group is changed, right? So example, this one. So in this case, is this similar? it may look like seal but not. So this one is a alcohol. This one is a ether. There is a thing called ether, right? Okay. Ether. So, but both have same chemical formula. Okay. Both are having same chemical formula. C3H7 sorry H8O. C3H8O, right? And another example, this one is a ketone, but this one is aldehyde. Right. What is the formula? So write down this example. C3H6O. So these are very simple, right? Very simple things. Right. Then after that, on next one, before that, let's write down the classification, right? Classification of these isomers, right? So we learned constitutional isomers, and there is another type called stereoisomers. So mainly isomers divided into two types, right? There are different classifications, right? So in your level, it's mainly divided into isomers mainly divided into constitutional isomers. So what are the categories? Chain isomers, and then position isomers, functional group isomers. And then this one, so copy the chart. Isomers again divided into stereo isomers. Then it's divided into two. Those are called enantiomers. The stereomers. Right. So write down this classification. Right. Then, so after constitutional isomers, so we done all those things. Then we have to talk about stereoisomers. Okay. Write down the subtopic stereoisomers. So what kind of isomers are called stereoisomers? What kind of isomers? In this kind of isomers, the structure also, it looks like similar, right? When you just looking at the structure, right? No any changes, no any carbon chain different, right? No any functional group different, right? No any arrangement of the functional group difference, right? So in this kind of molecules, what kind of difference we can see, we can observe the structure also looks similar, but the 3D arrangement, it's a difference of 3D arrangement. 3D, I mean, it's like very similar, but it has different arrangement, right? 3D, right? 3-dimensional arrangement, right? But it looks like similar, right? Not like constitutional ones, right? So you may understand when we discuss it, right? And another thing, we cannot in stereoisomers, another specific thing, there is a thing called I think you know, superimposable. Superimposable means let's take our left hand and right hand, so we cannot just superimpose it, right? But it looks like you can keep it like this, but you cannot just superimpose that. That means just replace your, can you replace your right hand by left hand? No, you cannot, because that kind of different. Can you see the difference, right? So these stereoisomers have that kind of difference, but it's similar, right? Both hands are similar, but you cannot superimpose them, right? You cannot, so if you have the idea, I mean, you cannot put your left hand into the right hand glove, right? Right hand glove, you cannot put the left hand into right hand glove. That's it, right? දැන් surgical gloves ගැන හිතන්න බෑ. surgical gloves එකේ අර දෙපැත්තම equal හින්දා තමයි ඒක දාන්න පුළුවන්. දැන් අපි අර surgical gloves කියලා කියන surgical gloves types තියෙනවා. අර මේ normal gloves වල එහෙම බෑ, right? උඩ යටයි දෙකක් කියලා එකක් තියෙනවා. එතකොට set වෙන්නේ නැහැ. right? Surgical gloves මතක් කරගන්න එපායි. හරි. අර normal gloves මතක් කරගන්න. ඒතරට මෙහෙම ඇතුළට දාන්න බෑ. Replace කරන්න බෑ. You cannot replace it. දාලා super impossible. We call it super impossible. මෙහෙම ඔබ්බන්න. Right? If you are a ghost, right? Your left hand is a ghost, but you cannot fill it, right? Right. Okay, write down. Stereoisomers are compounds. Stereoisomers are compounds with the same molecular and structural formula. With the same molecular and structural formula. But different 3D orientation. Of bonds. Next point. Atoms are connected in the same order. But arranged differently in space. Next point. These structures cannot be superimposed. On each other. Superimposed on each other. Right. Okay. Then write down the subtopic. So we have there are two types of stereoisomers. So one is diastereoisomers, right? So write down small topic, diastereomedicine. Diastereomedicine, right? So diastereomedicine means we identify this stereoisomers as not a mirror image of each other, right? Mirror images නෙවෙයි, right? But you cannot superimpose it, but not the mirror image, right? يعني එකක් අරගෙන අනිත් එක ඉස්සරහින් තිබ්බහම ඒකේ හැදෙන එකක් තියෙනවා. අන්න ඒ වගේ ඒවා නෙවෙයි මේ. ඒක දැන් කොහොම කිව්වට තේරෙන්නේ නැහැ. ඒක එක්සැම්පල් එකක් එක්ක බලමු, right? එතකොට මේක අපි ගමු here. Let's take CC double bond carbon, right? So we talk about diastereomers, about this CC double bond carbon, right? With this kind of structures, right? We can talk about diastereomers. So let's move to the example. So actually this is a requirement, huh? So without double bond we don't talk about diastereomer. Right. Uh, right. So this we can talk about this diastereomers. Uh, as I said, uh, around the CC double bond, right? So what kind of arrangement? So actually this is a 3D arrangement, as I said from the beginning. Here these changes, these are the differences about 3D arrangement, right? So in this case, so there are 4 different type of groups, right, or atoms around this carbon, right, here also. So you can think this double bond, so it's like two ropes, right, it's like two ropes, right. So when you try to rotate, what will happen? It don't, I mean, not as a two ropes, just take it as a two rods, metal rods, right. This carbon bind with two metal rods. What will happen when you start to rotate? So you can rotate only 180-degree angle. Why? It will cross, right? So if those are the rods, right? So when you try to cross it, what will happen? It will make a cross, right? You cannot rotate it more than 180, right? So the same thing, right? So this double bond is limit the rotational movement, right? We only rotational. These molecules can move, right? Atoms can move in the molecule. So then due to that, look at this different, right? This one, it's just rotate 180 degree, right? It's rotate 180 degree. And another thing, just before you consider about the uh, isomer, right? I mean, it's diastereomer. Just think whether it can, not only diastereomer, whatever, right? Whether it can superimpose or not, right? If it can superimpose, it's not a stereoisomer, right? It's not an stereoisomer. The main character of stereoisomer, whether it's diastereomer or other type, it's not superimposed, right? So can you superimpose these two? No, we cannot, right? We can't. So therefore, are they mirror images of each other? The mirror එකක් ඉස්සරහින් මෙයාව තිබ්බොත් මෙයාව පේනවද? එහෙම පේන්නේත් නැහැ. mirror එකකින් තිබ්බට එහෙම පේන්නේ නැහැ. right? මෙයාව තියන්න බෑනේ. මෙයාව තිබ්බට මෙයාව පේන්නේ නැහැ. Therefore, these are not mirror images also, right? This kind of structures, so we can call diastereomer of each other, right? They are diastereomer of each other, right? That's the idea. That's the key idea. Then, so as I said, what are the requirements? You need double bond, right? And 4 different type of molecules, or you need similar molecules into opposite carbon, right? Similar molecules into opposite carbon, not the same carbon. If you get the similar molecule into same carbon, let me give some example. So this one, these I'll write. These are diastream of each other. Because we cannot superpose. Right. So let me draw another one. So think about these two. When you change it, what will happen? So even after 100-degree rotation, right? Just think you rotate it. They are similar, right? Even after rotating 100 degrees Celsius, right? Nothing changed. Change කරත් එකමනේ තියෙන්නේ. මේක නේ වෙනස් වගේ තිබ්බට මේක super impossible, right? මේක දාන්න පුළුවන් අනිත් පැත්තට. ඒ rotate කරපු එක උඩින් අනිත් එක තියන්න පුළුවන්. මේකෙන් මෙහෙම බැලුවමට බෑ. හැබැයි මේක අරගෙන මෙහෙම කරලා තිබ්බයි. හැබැයි මේක එහෙම තියන්නත් බෑ. right? මෙහෙම rotate කරපු එක උඩින් අරගෙන අනිත් පැත්ත ඇවිල්ලා ගහන්න බෑනේ. හරි. තේරෙනවද? එහෙම ගහන්න බෑ. කියන්නේ මේක මෙහෙම මේ තියෙන එකුයි දැන් මේ QPs මේ equal කරන්න හිතන්නකො දැන්. හරි. කියන්නේ මේක මෙහෙම ගිඩිය පිටින් අරන් ගිහලා මෙහෙම තියනවා කියලා හිතන්න බෑනේ. ඒ කියන්නේ මේ ඒක යටට යන්නේ එතකොට. මෙහෙම තියෙන එක මේක සුපර් ඉම්පෝස් කරන්න හදනවා. එතකොට මේක ගෙනල්ලා වගේ හරි P එක මෙහෙම යටට තියෙන මෙහෙම උඩින් ගන්නවා. එතකොට ඒක යටට යනවනේ මෙතන. B එක උඩට යනවා. හැබැයි මේකේ මෙහෙම තියෙන එක මෙහෙම ගෙනල්ලා මෙහෙම තිබ්බොත් එහෙම මොකද වෙන්නේ? මෙහෙම තියෙන එක මෙහෙම ගෙනත් ගන්නවා. සිමිලර්. right? දෙකම එකක්. හරි? සුපර් ඉම්පෝස් වෙනවා. එතකොට මේ එහෙම වුණොත් diastereomers මේ නෙමෙයි. right? So these structures. just write down before you write the example. So here it's different, right? Similar with the other. Right. Write down diastereomers are stereoisomers. Diastereomers are stereoisomers. 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 Stereoisomers that are not mirror images. 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 That are not mirror images of each other. That are not mirror images of each other. Next point, they have the same molecular formula. They have the same molecular formula. They have the same molecular formula and connectivity. They have the same molecular formula and connectivity. They have the same molecular formula and connectivity. Connectivity, but differ in 3D arrangement of the atom. But differ in 3D arrangement of atom. Right. Next point, geometric isomerism is one occasion. Geometric isomerism is one occasion. Geometric isomerism is one occasion where diastereomerism is seen. Where diastereomerism is seen. Next point, CC double bond has a sigma bond and CC double bond has a sigma bond and a phi bond. A sigma bond and a phi bond. Sigma bond and a phi bond. A sigma bond and a phi bond. This phi bond prevents free rotation. This phi bond prevents free rotation. So the atoms around C double bond C. So the atoms around C double bond C stay in one plane. Stay in one plane. Stay in one plane. Right, next point. Next point. Each carbon of the double bond, 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 each carbon of the double bond must have two different groups, 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 must have two different groups to geometric isomerism, to geometric isomerism exist, to geometric isomerism exist. To geometric isomerism exist. Right. Then in this case this dash stereomers depend on the structure. There are two types called cis and trans, right? Trans, right? Not normal, not LGBT, not LGBT trans, right? It's a different structure, right? It's about arrangement, right? It's about the arrangement of group, right? So I'll explain it later, right? So just for now, just write down. There are two. Next point. There are two possible arrangement. There are two possible arrangements. There are two possible arrangements. Next point. There are two possible arrangements. There are two possible arrangements. There are two possible arrangements. Cis, we call cis isomer. Let's write cis isomer. Cis isomer. How it's become cis? Similar groups on the same side. Similar groups on same side. Similar groups on same side. Just write down. Cis isomer. Similar groups on same side. Then next one, trans isomer. Trans isomer. Trans isomer. Similar groups on opposite sides. Similar groups on opposite sides. Similar groups on opposite sides. Right. in the next rule, these isomers, next point, these isomers, so this is like a summary, right? These isomers, just write these isomers and then down by down, these isomers and then down by down, write down by down, differ in spatial arrangement, down by down. First one, differ in spatial arrangement. Second one, cannot interconvert by rotation. Cannot interconvert by rotation. Next one, are not superimposable. Right? Just highlight those facts, right? That's the final idea, right? Then write down these examples, right? These two. Here, then copy the structure and then write down these compounds are the stereoisomers because we cannot superimpose on each other. Second one, these structures can superimpose on each. This copy this one and then write this. These structures can superimposed on each other, right? Right. Then write down the small subtopic, cis and trans nomenclature. Cis and trans nomenclature, small subtopic. Cis and trans nomenclature. So let's talk about properly which is cis, which is trans. Okay. What are the conditions to become cis or trans? So first, that molecule should have double bond, right? Then wait. මොකද්ද මේ මෙහෙම අඳින්නේ මේක දරුවෝ the meaning of short line the මේ surface එකෙන් ඇතුළට තියෙන්නේ. කියන්නේ මේකෙන් කියන්නේ මේක අපි කලර් කරන්න ඕනේ. මේ කලර් කරපෙන් කියන්නේ උඩට. මේ surface එකෙන් එළියට කියන එක. right? තමයි meaning එක මේ කලර් කරලා ගන්න ඕනේ. හරිද? එතකොට become molecules atoms මේක දැන් මේ මොලිකියුල් එක තියෙන්නේ මේ ප්ලේන් එකේ කියලා හිතන්න. මේ ප්ලේන් එකේ. කියන්නේ මේ කාබන් දෙක තියෙන මේ ප්ලේන් එකේ. Carbon atoms are placed on this plane, and so when which plane? So CH3 and CH3 groups, it's more little bit front, right? This way, right? But I mean that H hydrogen atoms move backward, right? පස්සට ගිහින් තියෙන්නේ. මේක front එකට ඇවිත් තියෙන්නේ. චුට්ටක් කාබන් මේකම ප්ලේන් එක තමයි බෑ චුට්ටයි වෙනසලා. right? ඊට පස්සේ මේකේ මෙන්න මේ මේකේ ඇතුලෙන් හරිද? ඒ කියන්නේ දැන් මේක ෆ්ලැට් තියෙන මේක මෙහෙම තියෙන්නේ හරිද? මේක දැන් මේ මෙහෙම ඇඳලා මෙහෙම තියෙන්නේ කියලා හිතන්න. මේකේ කාබන් දෙක මෙහෙම තියෙනවා. මේක මැද්දෙන් මෙහෙම ගහනවා මේ perpendicular wall එකක්, right? right perpendicular wall එකක් හරි. ඒ යටින් තමයි විත් තියෙන්නේ. ඒක දික් කරලා බලන්න. right ඒක මේක තියෙන උඩ මේක තියෙන යටින්. හරි. එතන එහෙම ගහලා තියෙනවා. Then so this is the is the plane of the molecule. That one, it's a plane perpendicular to the molecule. Right? මේ normal plane එක මෙහෙම නම් ඒකට මෙහෙම perpendicular වෙන්න ගහන්නේ. හරිද? එතකොට දැන් මේ elements කියන්නේ atoms හරි මේකේ මේ group එක හරි මොක හරි මේ plane එකෙන් පිටිපස්සේ තියෙනවා. හරිද? එන් පිටිපස්සේ තියෙනව දෙක සමාන නම් right? හරි ඉස්සරහා තියෙන දෙක සමාන නම් හරි. කියන්නේ එකම side එකේ යන මේ විදිහට right? කියන්නේ මේ plane එකට අපි මේ විදිහට plane එකක් ගියම මේ plane එකෙන් එකම side එක කරනවා. හරි. in or if it's in if it's out out. ඒ කියන්නේ මේක එළිය නම් මේ කියන්නේ plane එකෙන් අපි back එක කරනම් back දෙකම back. හරිද? මේකේ දෙකම ඉස්සරහා දෙකම ඉස්සරහා right? මේ වගේ situation එකකදී අපි මේකට කියනවා cis right? we call it as cis. හරිද? ඒ කියන්නේ cis කියලා. හරිද? cis structure එක. එතකොට ඒක තමයි අපි අර කිව්වේ same groups in the same side. හරිද? මේක දෙකම groups ටික තියෙන එක. මේ side එක කියන එක හොඳට මතක තියාගන්න. side එක කියන එක මෙහෙම දෙකට පළපු side එකක් නෙවෙයි කියන්නේ. හරි? මේ විදිහට plane එකක් ගහලා වෙන් කරපු side එකක්. හරි? ඕනනම් ඔයාලා කාට හරි ආගිය කියලා මේ මැද්දෙන් පල්නවා කියන මැද්දෙන් පල්න එක නෙමෙයි. In that case those are opposite, right? In that case these are opposite, right? Opposite groups. This is the way. මේකේ මේ plane එකෙන් same මේවා. Same groups in same side, right? එකම side එක. මේ වගේ arrangement එකකට අපි කියනවා cis arrangement එකක් කියලා, right? Right? Just basically understand this system state or give the idea about the arrangement, right? Arrangement of the atoms and the molecules, I mean the groups around the CC double bond, right? CC double bond. If it says cis, then you know this kind of arrangement. Then they say trans, what will happen? Trans කියලා කියන්නේ මාරු වෙනවා. මේ දෙක මාරු වෙලා මම එකක් පෙන්නන්නම්. අර අයිඩියා එක තියාගන්න මේක මෙහෙම මේ කියන විදිහට සෙට් වෙනවා කියන එක ඒගොල්ලෝ කියන්නේ ඒකයි වෙන දෙයක් නෙමෙයි. හරි. අපිට අර මේක අයිඩෙන්ටිෆයි කරගන්න හදපු සිස්ටම් එකක් මේක. හරිනේ. ඊට පස්සේ පොඩි සෙන්ටෙන්ස් එකක් දාගමු. Cis-trans arrangement described cis-trans arrangement described the relative position of two groups attached to different carbons in the same CC double bond right? So this is a cis arrangement, right? So this one is cis isomer. Right? We can write down this. Cis isomer, the right. Then same as this one, we can draw the trans one. Right. Trans එකෙත් ඔච්චරම තමයි තියෙන්නේ. In trans one, these two things will change. Right. H goes into here and CH3 goes into here. Right. So this thing, what will happen? මේකෙදි මේ දෙක මෙහෙම සෙට් එකක් වගේ තියෙන්නේ. right. මේ වගේ පොසිෂන් එකක තියෙද්දි අපි කියනවා මොකද්ද? cis මේ trans isom. කව් wait අපි මේකේ name එක දාගත්තේ නෑනේ කලින් එකේ. මොකක්ද දාන්න ඕනේ එතකොට? මේක name එක දාගමු. මෙහෙම ඉතින් අමුතු කේස් එකක් නෑ මේ normal name එක ඉස්සරහට මේ අපි කලින් තිබ්බ එක නේ. මේක කියන්නේ අපිට ලියන්න බැරි වුණානේ. නොවෙන්ටේජ් ඉවර. name එක දන්නේ CH3 මෙහෙම ඉද්දි. හරි. මොකක්ද දාන්නේ? cis කියලා ඉස්සරහට දාලා right. How to write the name? Just put the cis as a prefix, ne? Prefix, ne? Srada prefix, ne? cis කියලා දාලා ඔය normal විදිහට මේ ලියාගෙන යන්න. 1 2 නේ 2 cis 2 butanol. Sorry, I mean butene. Okay, ලකින්නේ cis 2 butene, right? එච්චරයි. name එකත් උතනම දාගන්න. ඊට පස්සේ අනිත් type එකට trans එකේදී H goes into here and CH3 goes into here. Right. So what is the name? මේ cis එක trans වෙනවා එච්චරයි. දැන් ඔයාලා බලයි මොකක්ද යකෝ මේ මගුල මේකේ මේ කිසිම වෙනසක් නැහැ නේ මේක නෑ මේකේ මෙහෙමයි ඇත්තට වෙනසක් තියෙනවා. ඕකය මේ ඔය සුපර් ඉම්පෝස් වෙන්නේ නැහැ කියන එකත් එක්ක ඕකය මේ නැචරල් ඒ කියන්නේ ඒ රියැක්ෂන්ස් වෙන විදිහට ඉෆෙක්ට් වෙනවා තමයි. හරි? කියන්නේ ඒක හැම රියැක්ෂන් එකකටම නෙමෙයි දැන් ස්පෙસિෆික් ඒවා තියෙනවා එහෙම. Especially in natural reactions, something like biochemical reactions, right? I mean, reactions inside of your cells, right? In your body, right? දැක්කම මෙඩිසින් එකේ සිස් එකයි ට්‍රාන්ස් එකයි දෙවිදිහකට ඇක්ට් කරන්නේ, right? يعني එහෙම හිතා ගන්නකො. ඒ කියන්නේ අර මොකක් හරි තැනක ෆිට වෙන්න නිකන් ස්ට්‍රක්චර් එකක් තියෙනවා කියලා හිතන්නකො දරුවෝ. හරිද? يعني මොකක් හරි එකක් තියෙනවා ඒක මේ මොලිකියුල් එක ගිහින් දෙන්න ෆිට වෙනවා කියලා, right? අන්න ඒ වගේ මේක වෙනස්. ඒ ෆිට වෙන්න බෑනේ. අරක ෆිට වෙච්ච එකට මේක ෆිට වෙන්න බෑ. අන්න ඒකයි ඔය 3D ස්ට්‍රක්චර් එකේ අවුල. يعني මේක දැන් අරවට වැඩිය මේවා එකම වගේනේ. right? The first three types chain functional group those are totally different, but this one looks very similar. Even they show different chemical properties, right? Not physical, not that much physical. Basically chemical. I mean, even in the chemical is specific reaction. Burning, nothing happens. When it's burned, just burn, right? The structure doesn't matter, right? It will burn, right? But in some biochemical reactions, those are matters, right? Okay, matter වෙනවා එතකොට. මේක draw කරගන්න. මේක draw කරගෙන ලියන්න trans isom. දැන් අර අපි මුලින් යන දෙක ඩයස්ටරියම් මේ ඩයස්ටරියම් අයිසොමරිසම් එක පෙන්වනවා ඩයස් මේ but not cis trans එක කියන්නේ අරකේ තව කෑල්ලක්. ඒකේ තව සබ් කෑල්ලක්. හරි? ඒක පෙන්වන විදිහක්. හරි? ඒකේ අර ජියොමෙට්‍රික් එකක් යන්නේ. මේක ඩ්‍රෝ කරගන්න. right ඊට පස්සේ එක්සැම්පල් එක තව එක්සැම්පල් එකකට යන්න. එතකොට මේක කියද්දි ඔයාලට කියන්න පුළුවන් මේක මෙහෙම කියන්න පුළුවන් ජියොමෙට්‍රික් අයිසෝමර් of මොකද්ද මේ cis මේ sorry trans 2 මේ කියන්නේ අර මෙහෙම කියන්න පුළුවන් දැන් cis 2 butene එකේ මේ අනිත් අයිසෝමරිසම් එක right අන්නේ type එකකින් කියන්නත් පුළුවන්. එහෙම කියන එක තේරෙනවනේ කියන එක අර අනිත් එකේ නිකන් අර අනිත් කෑල්ල වගේ ඒ මීනින් එකකින් කිව්වේ. හරි? අනිත් පාර්ට් එක වගේ. ඊට පස්සේ තව එකක් දාගමු. මේකක් දාගමු එක්සැම්පල් එක. මොකද්ද මේ එතකොට නමක් කියන්නකෝ. මේක අන්න මතකද දන්නේ මේ මොකේද second lesson එකේදී මේ වගේ වන්දන මතකද නෑ. මොකද්ද මේකේ නේම් එක එතකොට cis මේක cis කියලා ලිව්වේ. cis මොකද්ද මේක trans එක. cis dichloro 1,2 dichloroethene, right? Cis 1,2 dichloroethene, and this one trans 1,2 dichloroethene. Again trans. හරි කද්දා ගන්න. Next on enantiomerism. Right, write down the subtopic enantiomerism. enantiomerism. මේකෙදි මොකක්ද enantiomerism කියන්නේ? Enantiomerism means if your molecule that isomerism formed as a mirror image, right? So let's say this is your molecule, right? So if its isomer formed it as a mirror image, which is not superimposable, right? Superimpose කරන්න බැරි විදිහට mirror image එකක් විදිහට form වෙනවා නම් හරිද? අන්න ඒ වගේ එකක් තමයි මෙතන කතා කරන්නේ, right? Enantiomers, right? So I'll say again, if the isomer formed as a mirror image which cannot superimpose, right? Here we are, right? Make I'll give example. Carbon. Right. Okay, this is a mirror. Right. Okay. Look at these structures. Right. There are two structures. Right. So let's say this is a mirror image of that one. Right. Then mirror එකකින් ඉස්සරහින් මෙහෙම මේ යටතුන හිතන්නකො mirror එකකින් තියලා වගේ තියෙන. Then it looks like both are similar. Looks like very similar. But can you superimpose these two? මේකව මේකෙන් අරගෙන මෙහෙම superimpose කරන්න පුළුවන්ද? පුළුවන් කියලා හිතන්නේ බැලු බැලමට පුළුවන් වගේ. හරි? ඒ බැලු බැලමට පුළුවන් වුණාට මේ කරන්න බෑ. හරි? කරන්න බෑ කියන්නේ නිකන් මෙහෙම අත් දෙකක් තියලා වගේ තියෙන්නේ මෙහෙම. right? يعني අත මෙහෙම අරගෙන ආපහු superimpose කරන්න බෑ. දැන් ඔයා මේක මෙහෙම අරගන්න 3D හිතන්න. මෙහෙම අරගෙන ඒ කියන්නේ මේකේ ඇත්තම කතාව දැන් මේගොල්ලන්ගේ ඕඩ එක ගත්තොත් එහෙම ඒ කියන්නේ මෙහෙම ක්ලෝරින් ෆ්ලෝරින් හයිඩ්‍රජන් කියලා ගත්තොත් එහෙම එහෙම එකම මේ يعني එක ඩිරෙක්ෂන් එකකට සෙට් වෙන්නේ නැහැ මේක. දැන් මෙයා මෙහෙම අරගෙන මෙහෙම දාන්න හැදුවට එහෙම සෙට් වෙන්නේත් නැහැ. හරි. යනවා දැන් මේකව මෙතෙන්ට එහෙම කරකවුවොත් එහෙම F එක මෙතෙන්ටයි එහෙම දෙකක් සෙට් කරේ අනිත් එක කියන්නේ පැටලෙනවා. හරි. ඔන්න තව 3D පෙන්නන්න. මේ this kind of isomers we call enantiomers, right? Or we especially call chiral carbon. This kind of carbon we call chiral carbon. Again, මේ carbon so how do you find this kind of arrangement? If carbon has 4 different type of groups, 4 different groups, it doesn't matter whether it's hydrocarbon or whatever, right? If carbon combine with 4 different compounds, it will call that carbon will call chiral carbon, right? Chiral carbon, or we call it chiral center. එතනට අපි කියනවා chiral center එකක් කියලා. හරි? එහෙමත් කියනවා. ඒකට ඕන ස්පෙસિෆිකල් නේම් කරන මේක chiral carbon. Just write down isomers which are mirror image of each other. Isomers which are mirror image of each other isomers which are mirror image of each other are known as enantiomers. Are known as enantiomers. Next point, a compound having a carbon atom which is joined to 4 different groups shows enantiomers. Right. A compound having carbon atom which is joined to 4 different groups shows enantiomers. Next point, such a carbon atom, such a carbon atom, such a carbon atom such a carbon atom is known as such a carbon atom is known as an asymmetric or chiral carbon, an asymmetric or chiral carbon. An asymmetric or chiral carbon. Okay, then draw the diagram. Draw it properly. ඔය දෙකේම chiral තමයි ඒකත් මේ මෙන්ෂන් කරන්න. Right. Then next, so after draw this one, just write down chirality center. Chirality center is a tetrahedral carbon. Chirality center. Write this as a paragraph. Chirality center is a tetrahedral carbon atom. Tetrahedral carbon atom that is bonded to four different groups. That is bonded to four different groups. The presence of a single chirality center. Single chirality center in a molecule guarantees that the molecule is chiral and the enantiomeric forms are possible. Guarantees that the molecule is chiral and the enantiomeric forms are possible. Right? So, to understand the mirror image case, right? So, I'll give some objects. So, just try to say whether it's I mean enantiomeric or not, right? I'll give some examples, right? Some objects, so guess whether it's chiral or chiral. Chiral means that, do you know that name, how that name came from? Chiral means I think in Greek or something, the chiral means hand, one of the name for hand, right? So this like hand, the relation between hand, right? The structure. So that's why I call chiral, right? So a chiral means no chiral, right? And chiral is absent, we can call a chiral, right? So if both in this kind of structure, let's say there are two hydrogen, then it will become a chiral, right? Now you can superimpose easily. ඒක දාන්න පුළුවන් මේක මෙහෙම ෆිට කරගුවා ෆිට වෙනවා. හරි. දැම්ම ෆිට කරා. ඕක ෆිට වෙනවා. එහෙම දැම්මොත් ෆිට වෙනවා. يعني ගේමම නෑ. හරි. මොනවද මම අපි දැන් දේවල් ටික කියමුකෝ. බලන්න මේ ටික මොනවද කියලා. මේ මම කටි කියන්න නිකන් හිතන්න. ස්ක්‍රූ ඩ්‍රයිවර්. ස්ක්‍රූ ඩ්‍රයිවර් එකක් chiral ඒ දෙක සුපරිම්පෝස් කරන්න පුළුවන් නම් එච්චරයි. පුළුවන් ද සුපරිම්පෝස් කරන්න? බෑනේ බෑ. බෑ නෙමෙයි පුළුවන්. මොකද බැරි. හරි. බැරි නෑනේ. just screw driver එකක් තව ඒ වගේකින් ප්ලේස් කරන්න පුළුවන්. ඊට පස්සේ ටෙනිස් ෂූ. දැන් අපි ෂූ එකක් ගත්තාම අපි left side එක ගත්තොත් ඒක සුපරිම්පෝස් කරන්න බෑනේ. right side එකකින් වගේ හරි. ඒතකොට ඒකේ chirality එකක් තියෙනවා. එක සයිඩ් එකක් තියෙනවා. බාස්කට්බෝල් බැට්, බේස්බෝල් බැට්. බේස්බෝල් බැට් එකේ තියෙනවා නෑ නේ ලෙෆ්ට් රයිට් කතාවකුත් නෑ නිකම්ම බැට් එක. කාර් එකක් පුළුවන්. කණක් අපේ කණක් සුපරිම්පෝස් කරන්න පුළුවන්. තව එහෙම බෑනේ. අනිත් කණින් සුපරිම්පෝස් කරන්න එහෙම බෑ. ඒ වගේම ස්ට්‍රක්චර් එකක් ස්පෙસિෆිකලි හදන්න. ඒකේ තියෙනවා ඒ chirality එකක්. හරි. ගෝල්ෆ් ක්ලබ්. ගොල්ෆ් ඒකත් chiral. ඒ chiral එක normal bat එකක් වගේ නෙමෙයිනේ. ඒක ස්පෙસિෆිකලි අර සයිඩ් එකකට තියෙනවානේ. ඒ කියන්නේ දෙපැත්තෙන්ම ගහන්න බෑනේ අරගෙන. දැන් පිටිපස්සේම ලොක් මේව කරලා හදලා තියෙන්නේ. ඒක සයිඩ් එකනේ තියෙන්නේ. එතකොට ඒක ඔව් ඒක chiral නේ. හරි. ඊට පස්සේ මේක පොඩි ඩයග්‍රෑම් එකක් පෙන්නන්න තව ඔකට. අපි අර බුක් එකකින් දෙකක් බලමු. මෙන්න මේක පොඩ්ඩක් බලන්න. මේකෙන් තව පොඩි අයිඩියා එකක් ගත්තා. මෙන්න මේ ස්ට්‍රක්චර් පොඩ්ඩක් බලන්න. මෙන්න මේක. තව හොඳට බලන්න ඕක සුපරිම්පෝස් වෙනවද නැද්ද කියලා. ඒක දෙක සෙට් කරන්න ගියාට සෙට් වෙන්නේ නැහැ. තේරෙනවද? හරි. වෙනස් විදියට පයින් හොදලා බලන්න. හරි. ඒක සෙට් වෙන්නේ නැහැ. හරි. ඊට පස්සේ පොඩි ක්වෙස්චන් එකක් දාගන්න. example question එකක්. does 2-bromopentane na does 2-bromopentane bromo මේක දාමු. does 2-bromopentane have a chirality set? මේ chiral set එකක් තියෙනවද කියලා බලන්න තියෙන්නේ. කොහොමද බලන්නේ? ඇඳලා තමයි බලන්නේ. ඒක බලන්නේ නැහැ. හරිද? නිකන් අඳිමුකෝ මේක. pentane උට පහක් අඳිමු. C 2 bromo නේ. දැන් බලන්න මොකක් හරි දැන් මේක ස්ට්‍රක්චර් එක ඇඳලා බලන්න. මේ වැඩි තේරෙන්නේ නැත්නම් හැම කාබන් දිහාම බලන්න මොන කාබන්ටද අර වෙනස් જાතිය හතරක් තියෙන මොකක් හරි එකක් තියෙනවද කියලාමයි. හරි සිම්පලි එච්චරයි. හරිද? one by one check කරගෙන යන්න ඉතින්. වැඩේ අමාරු වගේ තමයි. articles ඔක වැද්දා check කරන්න. මෙයාගේ H4ක්. මෙයාගේ Br එකක් තියෙනවා. මේ සයිඩ් එකෙන් CH3 group එකක්. right. Br එක මේ සයිඩ් එකෙන් CH3 group එකක්. හරි. ඊට පස්සේ H එකකුත් තියෙනවා. හරි. ඊට පස්සේ ආයි C3H 7. හරි. එහෙම group එකක්. දැන් මේකේ කයිරල් මේක කයිරල් නෙමෙයි මේ ಜಾති හතරක් නේ තියෙන්නේ. ඔන්නම හතර හොයාගන්න පුළුවන් නම් එච්චර එක්සෑම් එකේදී ඕව වෙනවා. හරි. ඔයාලට එක්සෑම් එකේ තියෙන essay structured essay එකේ fourth question එකේ තියෙන identifications. identifications වලදී අනිවාර්යෙන් මේවා තියෙනවා. හොඳට බලන්න. ඒතකොට කයිරල් තියෙනවා ගමන් මොන වගේ තියෙන්නේ කියලා හිතා ගන්න පුළුවන් විදිහට. ඒක තමයි skill එක. ඒක ඉස්සෙල්ලා කයිරල් තේරිලා ඉන්න ඕනේ මොකක්ද කියලා. ඕකේ එතකොට මිරර් ඉමේජ් එක ඇඳොත් එහෙම ඒක කොහොමද? ඒකත් ඔබම දෙක සෙට් වෙලා ඉන්න නැන්ද හරි. ඒක අවුලන්නේ මේක තියනවා කියලා තේරුම් ගන්න ඕනේ මිරර් ඉමේජ් කතාව ඕනේ. ඊට පස්සේ මම දෙන්න හෝම්වර්ක් එකක් මේ සෙට් එක මේ මොලිකියුල්ස් ටික දාගන්න මේ ටික කයිරල්ද කියලා හොයන්න. ඒ 2-fluoropropane 2-methyl butane trans මේකේ මේ කලර් මේ තියෙන මේ ඩ්‍රෝ කරලා බලන්න මේ අයිසෝමරිසම් එක මොකක්ද තියෙන්නේ කියලා ඔයාලා සෙට් කරලා බලන්න මොකක් හරි ඒ තියෙන අයිසෝමරිසම් එක ලියන්න මේ කයිරල් විතර නෙමෙයි තියෙන්නේ. pentane fluoropropane methyl butane trans 2 butene bromopentane 2 chlorobutane 2 methyl butanol. Right, so find what kind of isomers you can find. Most of molecules have I think chiral maybe trans again tibuti. හරි ඒක බලන්න ඩ්‍රෝ කරලා බලන්න. මේක අනිවාර්ය ස්ට්‍රක්චර් එක ඩ්‍රෝ කරලා බලන්න ඕනේ නැත්නම් හොයාගන්න බෑ. ස්ට්‍රක්චර් එක ඇඳලා තමයි බලන්න ඕනේ. ඉතින් හිතන්න අමාරුයි. ඔයාලට කොහොමද බෑනේ. හරි. ඒතකොට මේක try කරන්න. එතකොට මේ lesson එක ඉවරයි. මම මේකට වෙනම slot එකක් දාන්නම්. මේ organic part 1 හරි මොකක් හරි කියලා. නැත්තම් unit 7. unit 7 එක මෙච්චරයි තියෙන්නේ. කියන්නේ nomenclature and isomerism. හරි. ඔය ටික තියෙන්නේ MCQs වෙනවා structured එකට මේ isomerism part එක ඕන වෙනවා. හරි. එච්චර තමයි. ඒක තමයි ඕන වෙන්නේ. essay එකට මේ isomerism ලොකුවට ඕන වෙන්නේ නැහැ. nomenclature isomerism ඕන වෙන්නේ නැහැ structure එකට. sorry essay එකට. මේ ටික බලා ගන්න. right? එහෙනම් good night අදට නවත්ත.